In this question, it states, when I roast broccoli for dinner, I like to use lemon juice to finish the dish. I find that acidity in lemon juice brightens the flavors. The main acidic component in lemon juice is citric acid. And then it gives you the chemical formula. So before we panic about the chemical formula, let's keep reading. It says, citric acid is a triprotic acid. Hey, this formula looks a little bit more common, H3C6H5O7. So that tells us that we know that these hydrogens here are going to be our acidic protons. So the counter ion is the citrate ion, which is C6H5O7 3 minus. In order to determine the concentration of citric acid in 100 milliliters of lemon juice, I conducted a titration reaction with potassium hydroxide. In order to reach the equivalence point, I used 52.16 mils of a 0.612 molar potassium hydroxide. What is the concentration in molar of citric acid in the sample? We have two hints. Make sure the acid protons and base units cancel, and you need a balanced equation. So citric acid isn't one of the strong acids that you had to memorize. And for the purposes of this question, we are going to assume that all three protons come off. And so we know that we have H3C6H5O7. Then we're going to add potassium hydroxide. That's one of the strong bases you had to memorize, so it's KOH. And then we know when you add an acid and a base, we get salt plus water. Now, we know we have water, so that's simple. But the other one might feel a little confusing, except we know the counter ion. So we know that that's going to split out. And so we have K3 plus C6H5O7. So in order to have this, we're going to need 3 potassiums. We also are going to have 3 water in order to balance. Now, you might have realized, hey, if it is triprotic and monobasic, you might have been able to make a 1 acid plus 3 base units equation. That will also help you. So now we have a balanced chemical equation. So now we can solve the titration. Titrations are simple. We have a balanced equation. So we want to figure out the moles of the known. So our known samples are my potassium hydroxide. So I'm going to take my 0.612 moles in 1 liter and multiply that by 0.05216 liters. And that's of KOH. So once we figure that out, we can just keep going. So for every 3 moles of KOH, we need 1 mole of H3C6H5O7, or citric acid. And so that's going to give you 0.0106 moles. Then we have a 100 ml sample, so 0.1 liter. And then when you plug this in, you're going to get 0.106 molar. So here at the beginning, we converted to determine moles of known. That wasn't helpful. Moles of known. That's what happens here. Here is the moles of unknown. And down here at the very bottom, this is going to allow us to determine whatever the question asked. In this case, it asked for the concentration.